mode.
A lot of people.
Start again.
Hi, this is Dave Farmer. We're going to have a webinar today that is on flow sensors, and Creative Sensor Technology makes a really advanced flow sensor product line, and we're going to be hearing from them, and then I'm going to show you how to use those flow sensors. And it's going to be pretty cool. I think this is something that's going to interest everybody. And we have an introduction to a new detail system also in here to show you how to, without doing anything special, getting their details available to you. So what I'm going to do is I'm going to turn this over to Norm Bartlett. He's the president of Creative Sensor Technology, and he'll give you a quick rundown of the product line, give you a little presentation of his product line. Then I'm going to come back and then show you how to use those in actually 5 different ways in a project. So the complexity can be quite interesting here. And Norm, you're up.
Well, thank you, Dave. I'm glad to be here with you today and have this opportunity to share some info about our Creative Sensor Technology flow products. I hope that we can go through this fairly quickly, but also have enough detail to hopefully answer all the questions people might have. Hi, everyone. I'm going to talk about flow sensors today, and I'd like to start with some basics for those of you who are new to the idea of incorporating flow. So if some of you are old pros at it, please bear with us for a little bit. We'll try and move along, but thought perhaps the best thing to do would be to cover some basics first. And I guess starting with the fundamental question is, why do we add flow sensors? And I think we can answer that pretty much as it's all about conservation. I'm sure all of you are aware or becoming aware of the need to conserve water. The irrigation industry has been under a lot of pressure in recent years to conserve water. I think we've been painted as the bad guys in the world by a lot of negative press, and you can understand that when you see water pouring out of leaks or things like that, or sprinklers running in the rain. So what we're trying to do here is add another tool to the irrigation system to become more efficient and to use water in a wiser and more conservative way. This whole movement about conservation has led excuse me, to smart controllers, ET-based scheduling, soil moisture sensors, and other high-tech advantages, to say nothing of spray nozzles and other things that have been improved over the years. But we're going to add flow sensors to it for a couple of reasons. One is to totalize flow. And as a flow totalizer, what you gain with a flow sensor is the ability to monitor your progress, how much water you're using, and then use that data to compare it with past performance, maybe before you initiated some retrofits of different kinds of nozzles or different kinds of control schemes. It gives you a basis of understanding whether or not your ET-based system is actually saving water, because it's giving you a total. So those are the kinds of things that we get out of a flow totalizer. And then the other part of flow measurement is rate detection, and what we use the rate of flow for more than anything else is probably to detect problems and create alarms. Now, one of the things we do is detect leaks, where we have failure of pipe or sprinklers, either because of problems with the product or because of vandalism or damage. And by detecting these leaks and things, we can fix something before it becomes a major problem. We also can find stuck valves, where perhaps we've got a valve that doesn't shut off at the end of its time schedule, and we're getting twice as much flow for a period of time through the system than was intended. And finally, we can also find valves that aren't working, say valves that either the solenoid is defective or the wiring has become broken, and we don't know that the water is not going to that area of the landscape, perhaps until the plant material starts to show signs of severe stress. So these are the basic reasons. Now, to give you a few graphics just for fun, let's talk about pipe breaks for a minute. This object down here in the bottom of the screen is a man standing there, so you can see the height at which the water is going. A broken 1.5-inch PVC pipe running at about a 50 psi pressure will discharge something on the order of 10,000 gallons in 30 minutes time. It'll also go to something on the order of 168,000 gallons if it runs overnight for approximately 8 hours. Or looking at it in another way, that's enough to cover an acre to a depth of 6 inches. So we've got some serious water losses here through pipe breaks. And just to make a point of this, all of the investment in high-tech equipment, ET-based controllers, smart controllers, soil moisture-based controllers, all of that savings can be wiped out with one pipe break. And it doesn't have to be a major thing. We can even look at small types of problems like leaks on a split riser on a spray head, or a spray head perhaps that doesn't even pop up fully. And we can discharge anywhere from 15 to 20 gallons a minute through something like this. And saying that another way, that's 200 gallons of loss every 10-minute cycle, or 8 to 1,000 gallons of water lost per week, or 25,000 gallons per season. Now that's one riser on one spray head. You can see where we go if we multiply this by a system that is poorly maintained or is subject to a lot of vandalism and things. So that's what you can see with it on the sidewalk here. What if it's somewhere where you can't see it and this builds up over time? So that's those are two of the main reasons. Another couple of things that might be worth pointing out is that we also have some public safety issues. This is a sprinkler head that is blown off of a riser, and now this geyser of water is going out onto the city street. It doesn't even have to be freezing weather in a place like this for this to be slippery and create a traffic hazard. And finally, as an example, again, to run through some things, we're also looking at protecting the property from damage caused by erosion and things. Here we have the irrigation pipe main at the top of this embankment. Obviously something is broken or leaked, and we've got all of this soil erosion coming down the side of this hillside. So there's a lot of things that can be detected by flow sensors and used in a way to shut things off, to conserve water, and to protect the property and the public safety. So that's a quick hit on why we want to include flow sensors. Now let's talk a little bit about why creative sensor technology flow sensors. First of all, our sensors are the first new flow sensor design in decades. Most of the industry is familiar with an existing paddle wheel sensor that was actually developed in the 1980s and really hasn't changed much in that time. We, however, have started a company in 2007 and started with fresh ideas and clean designs, and we've been able to make all new products that are technologically advanced. One thing that's worth noting is that our flow sensors are compatible with all irrigation controllers. Pretty much every controller in the industry that is capable or flow reading capable, or the ability to have a flow sensor input, can use our sensors. We've checked with the majority of the manufacturers and tested our sensors with their equipment to make sure that we could retrofit any old system, or we could be added to a new system without worry about the signal compatibility. And the other thing that is worth noting is that flow sensor is part of the system. You can look at that as the sensor, and you can look at the irrigation controller as the brains of the operation. So The sensor can't work as a standalone device. It works in conjunction with a smart controller, a pump control panel, or some other kind of monitoring equipment. The other thing we'd point out as to why to use our products is that they are designed specifically for the irrigation market. We have taken a look at the application, and believe it or not, it's a pretty rugged environment. We ask our equipment to be in an underground valve box subject to moisture, if not outright flooding. It has temperature extremes that go all the way from freezing conditions in parts of the country to desert heat, and we expect it to last in all kinds of weather and all kinds of water quality for an extended period of time. What we also point out with our equipment is that it has tremendous low flow performance. Most of the problems we have measuring flow in the irrigation industry is at the low end of the flow range, not the high end. So we've specifically designed these things to be much better on the flow at the low end. And we'll get back into that a little bit later. The other things we have is custom molded construction, so all of our parts are very uniform, which leads to better accuracy and better repeatability of the measurement that comes out of the device. We've also made it to be simple to install by putting a large jar top kind of a retaining nut on the top of the device and making it out of PVC with solvent weld connections on the ends. And we've built it in a way that we encapsulate the electronics for long service life. Now, just to go through the product offerings real quick, we have a T-type sensor that's available in inch, 1.5, and 2-inch sizes. And here's a cutaway view of it just to show you what it looks like inside. The body of the device is shaped like a T, and it looks very much like a PVC plastic pipe fitting. It is intended to be solvent welded onto the ends of the mainline piping. And then the detection system is this insert assembly that goes down through the branch of this custom T. This little two blades that you see here are part of the impeller that is spun by the water that goes through this T, and this impeller spinning rotation is detected by a set of electronics that are housed inside this assembly. The insert assembly, which is common to all sizes, carries the impeller down here. It contains the electronics in a waterproof housing in here. It's sealed into the pipe with an O-ring up here, and it's attached, as I said, with this large screw-on cover that holds it in place and sets it down into the flow at the end of the device. Now, some of the questions that come up sometime are about alignment and about the depth of things, particularly with some of the insert types of sensors. We've tried to take care of these variables in a way that we put a key on the insert assembly that lines up with a little direction arrow that we mold into the top, and we have an alignment slot in the T or in the housing of the saddle sensor that means that this thing basically only goes in one way. This shelf at the bottom of the insert chamber means that you can't put this thing any deeper than this, so that we always guarantee the correct alignment and the correct depth. Now, when we get into a little bigger sizes, we've just come out with two more product offerings, a 3 and a 4-inch saddle type sensor. We went with the saddle types rather than molding more T's for a couple of reasons. One, the most practical one is that this is an easier device to install on larger pipe sizes. We've talked to our customer base, and we determined that most of them were more comfortable adding a saddle type sensor over the pipeline than cutting a 3 or 4-inch pipeline and making a solvent weld joint. So this device actually clamps on over the pipe. It's kind of a clamshell arrangement in two pieces. It's held together with a wedge, and you pre-drill an 1.25-inch hole into the pipe, and the end of the insert housing actually goes down through the hole, and it's sealed by an O-ring on the outside of that housing. The nice thing about this product is that it's separate from some of the other insert sensors. There's nothing else to buy. It's all one piece that comes together, and it also, again, presets the alignment and the depth. It uses the same insert as the T-type sensors, so that the same structures are there for the guide on the front of it and the slot in this housing that's already affixed to the T, so that the depth and the alignment are controlled. Just going a little quickly into the installation part of it, which is important. We have this detail, and I think Dave's going to explain some of these a little bit more. But whenever obviously you're putting flow sensors in underground piping systems. They are mechanical devices. They do need to be occasionally serviced, so we always recommend that you put them in a valve box. It gives you access to the unit and locates the unit. You'll also see that we've got a couple of wires here that bring the signal from the flow sensor back to the controller. They should be thoroughly waterproofed when they're spliced together, and we've got a spec in here for a twisted shielded cable to run from the flow sensor back to the controller. This protects the signal integrity, and it keeps it from picking up interference from other electrical apparatus that might be wired in the same trench or in the same location. The other thing I want to point out to you here is that any flow sensor, ours or anyone else's, measures velocity through the pipe. It's measuring the velocity and turning it into flow, so we need to have a full pipe. It can't be accurate if there's only a half full pipe of water here. And it also needs some straight links of pipe ahead of it or down and downstream of it, so that it gets rid of some of the turbulence caused by changes in diameter or by fittings or valves or things like that. So when you do it, always put straight pipe, and when I say 10 diameters of the pipe ID, if you have a 1-inch sensor, this is 10 times 1 inch or 10 inches, but if you have a 4-inch sensor, this is 10 times 4 inches or 40 inches between the sensor and any kind of fitting or change in size. We also try and put 5 diameters downstream. So if we're doing something like this, we don't want to see the flow sensor and the master valve in the same valve box bolted basically together in the shortest possible distance. Please specify that you put these in their own access box, and they are at least 10 diameters away from anything upstream and 5 diameters downstream. Where do you put it in the system? Obviously, to measure everything in the system, we want to put it as close to the source as possible. So that may be the point of connection. There may be a vacuum breaker or pressure breaker here to prevent backflow. We want to put it immediately after that, and somewhere, if we're using a master valve, near the master valve, but again, observing the 10 and 5 rule to keep it straight pipe ahead of it and behind it. Now, sizing is probably the most critical thing I'd want to talk to you about today, and I know Dave is going to get in this a little bit more. But let's just go through this chart fairly quickly. As I said, flow sensors basically measure velocity. This column over here is a velocity chart showing the speed of the water going through the pipe in feet per second. Our flow sensors will go from a range of 1/4 of a foot per second, excuse me for that, up to a maximum of 12 to 15 feet per second. There is no hard, fast rule that the wheels will come off the flow sensor if it goes faster than this. This is just what we selected as a practical limit. As you probably know, most pipe designers will specify that you shouldn't run more than 5 feet per second through PVC pipe due to water hammer and other stress factors. So you can easily see that the flow sensor can handle much higher velocities than the plastic pipe can. What this means is that we can generally size the flow sensor for a flow range over this wide range from 1/4 of a foot per second up to 12 or 15, rather than size it to the pipe size that it's installed in. So if you have a system and you generally look at it and say, I'm going to put in a 2-inch main line because I may have upwards of 60 or 70 gallons a minute in a large turf zone, you don't need to put a flow sensor in that matches that 2-inch size. You might want to reduce the size by 1 or 2 sizes if the majority of your flow zones are much lower flows. And particularly, this becomes particularly critical when we've now found that most people are retrofitting systems, putting in drip irrigation in shrub beds and things, and generally reducing the size of some of the zones down to the 1 gallon per minute or down in that kind of range. Most other flow sensors in the industry today can't get close to these kinds of low flow ranges. So if you're looking at some of the other competitors, don't look at the high flow limit to their range, look at the low flow limit when you're comparing things. And again, just touching on this briefly, when you're downsizing a flow sensor, you want to put it in what we call a meter run, which is nothing more than the same 10 and 5 diameters of straight pipe before the meter and after the meter before you change pipe sizes. This means even in a 4-inch line, if you're reducing to a 2-inch meter, again to pick up this 2 to 3 gallon a minute low flow range, then you want to make your transitions, make your changes in pipe size back here about 10 diameters upstream, meaning 20 inches, and 5 diameters downstream, meaning 10 inches down here. So this meter run, as we call it, is going to be somewhere around 30 inches long. So again, just touching on that, size them for the flow range rather than sizing them for the pipe size. Now, a couple of other products I just want to touch quickly on, and these are accessory items that we've developed for the industry. One of them is called an ISOFlow device, and what the ISOFlow does is allow you to share a flow sensor between more than one irrigation controller. Obviously, there are several times when there are multiple controllers on a job. They may be all working from one point of connection. The trouble is that you cannot directly connect a flow sensor to the sensor inputs without either compromising the circuitry in the controller or getting false readings. So we developed an optical isolation device that allows you to connect the sensor to multiple controllers or to share a sensor between a controller and a pump station, a fertigation control system, or something like that without trying to figure out how to put in multiple systems. The ISOFlow 300 is a device that's used to share a flow sensor between 2 clocks, and the ISOFlow 6, ISO 6 as we call it, or the 306, allows you to share one flow sensor with as many as 6 controllers. What it does is it isolates the signal going out, and it also has some intelligence built into it so that it knows which controller is active, and it can block the flow readings to the other controllers so that they don't go into an unscheduled flow alarm. Now there isn't time for us today to go into that, so I'm just going to leave it at that and say if you have other questions on it, we can either talk about it offline, or you can certainly always call me or call CST, and we can answer your questions then. The final device I want to share with you a little bit this afternoon is a device that we call the combiflow. And what a combiflow does is allows you to share or combine 2 flow sensor signals into one, because most field irrigation controllers have a single flow sensor input. So if you have 2 different points of connection, perhaps you have alternate sources of water between a water harvesting system, rainwater recovery system, something like that, and potable water, you may have 2 different sources of water supplies or 2 different points of connection. You can combine these signals with this product into a single signal and go into the controller flow sensor input. These controllers, these flow sensors don't need to be the same size. They can be different sizes. They can even be different types. And this is a programmable box that allows you to mix these signals and then put out a single flow sensor signal that appears to be one central signal. Where do you use this type of device? Again, sometimes there's not enough straight pipe coming out of a pump house, and to install flow in a system, you have to put 2 flow meters in there. Another application is that you have a loop system, and you put 2 flow sensors in there because the flow can be coming from either direction to get to the zone valve. So these are some very quick overview of the product line. The only thing I can tell you is that we're here to help with any questions or any support we can. You can call us on the phone, you can email us, we can look at our website, or we also can be found on Facebook. So I'd say if you have any other issues that we can't cover in this brief seminar today, please feel free to call on us. And Dave, that's about as quick as I can make a quick run through the flow sensors. I hope that's what we needed to do for these folks.
I would call it fantastic. I'll tell you that. Very interesting. Okay, I'm coming back on. And Norm, I'm going to be showing some things. If you have any comments or you want to pitch in some ideas here, or even if I got something a little bit wrong, let me know.
I'll be glad to do so.
All right, very good. You can see my screen again. What I want to show you, I think is interesting, is 5 different ways to use these. 5 different kind of situations that could arise. The first one is the most simple. I have one point of connection. I got a meter with a backflow device. I have a master valve. Somewhere I have a controller, and of course this, main line is running around. So let's add a flow sensor to this, and we're going to give it a detail. And guess what? You already got the detail. You wouldn't believe it. You don't have the detail. You're going to download it from within AutoCAD. It's a pretty cool system we've created recently. So I'm going to go to the Irrigation Manager for this project, and I'm going to go over to, it's not a head, it's really not a valve, it's an auxiliary equipment. I'm going to go to there and click Add, and the type of equipment it is flow sensor. I say OK to that, and we've got some manufacturers, and here's CST. And the 4 products that Norm was talking about are on here. And they're on alphabetical listing, so you can look through, and I'm going to add all 4 of these by the time I'm done here. But this is my little common situation. I have this T-type, which would probably be the most common, 1 inch, 1.5 inches, and 2 inch. And then we have, if you need a bigger one, a 3 and a 4 inch. How do you know what size you need? I'm going to talk about here. I'm going to click on this first T-type here. So there you see the 1 inch, the 1.5 inches, and the 2 inch. And very importantly, the corresponding flow range that they're capable of. And notice that they go pretty far down. The 1 inch goes down to 0.86 GPM and up to 52, and then it's 1.8, 108, and 2.8 to 170, because we get a lot of situations where we have drip, and sometimes those drip can be down to even below 3 GPM on one valve. So we have to be careful about what the minimum is, as Norm said, and there's the maximum. I do want to show you our rules of thumb. This is a little sheet I keep bringing up in various little webinars we do, because it's kind of cool, and it just shows what would a typically rule of thumb for a water meter, a service line, control valve. But over here I have main lines on here. I'm running up to 1.5 inches at 5 feet per second, and then I shift to class 315 and I go to 2 to 6 inch, and I have a range of velocities, because with the bigger pipe, personally, I don't necessarily want to max them out velocity-wise. I want the velocity in a 6-inch pipe to be a little bit slower than 5 feet per second, because it's a pretty massive chunk of water moving through it with a lot of power. So I give a range. But the point is, what is the kind of flows you can expect out of this? I'm going up to 1.5 inches, and I can get 32. 2 inch, I can get 50. 2.5, maybe up to about 73, 65, 70, right in there, and you can see what these are. So let's just say, for instance, you had a 2.5 inch main line, and you were running about 70 GPM on it. What does that relate to in relation to this? You definitely want that flow meter small enough. The smaller the size, the more accurate it is on the lower end. So I had a 2.5 inch, maybe, and I had a 70 GPM maximum. I certainly want to look at my minimum. If my minimum was 2.5, I certainly don't want to use the 2 inch because the 1 inch can deal with 108 GPM. It can certainly deal with that high end, and now it's going to deal with that low end of 1.8, which is under my 2.5. That's real important to look at. And you go, oh my gosh, that's 1.5 inches on a 2.5 inch main line. That actually is very logical. We're only talking about a foot or two of pipe that is that smaller size. Your loss through there, as Norm pointed out, could be as little as what, 0.1 or 0.15 psi. It's very insignificant as a loss, even though it is a much smaller pipe size. So don't let that fool you, the fact that you could have a mainline pipe of 2.5 inches and this flow sensor sized 1 or even 2 pipe diameters less than that. Very easily done on that, and this would be 2 if that were the case. If my minimum were in the range of, let's say, 10 GPM, that's not being affected by the low end, I might pick a 2 inch flow sensor for my 2.5 inch size, if that makes you more comfortable. And the idea is there's no hard and fast rule other than it certainly is probably 1 pipe diameter, and it could very well be 2 pipe diameters less than your main line. So you pick one for that, and I'm going to pick this one right here and say add to my project on there. So I've added that particular flow sensor. Now I'll put it into the drawing by clicking on placing auxiliary equipment, the little backflow device, and there it is. I'll click place. I drop it in where I want it to go and give it a designation for it, and I'll remember that designation. I'm going to call it FS for flow sensor. It's sort of custom. And then I would pipe these together, and when I run the schedule, of course, that will be in it. I haven't set a detail for it, so let me go ahead and do that. I can do it from right in here in the project manager, and I don't happen to have any details in these projects. I got 5 projects, each one without any details in it. So I'm going to look at, there's my flow sensor. I'll hit detail. You do go to where our default is for flow sensors under here, but where I want you to go is to download a detail for this. And what you would do is you would scroll up. We call this standard details, and that name is just stuck from early days of Land Effects. I would call it a little bit different terminology today. There really are details and details that are filed by Construction Specification Institute Division. But up above that are just whatever categories you invent. You are going to have, if you have updated your Land Effects, this category, forget all these other ones here, I'm just messing around with those. This one called FX details is the important one. If I expand that, I'm starting to see some categories on there. Here is irrigation. I'm going to expand irrigation. And right now, we actually have about 4 manufacturers that we're going to be adding their details in, but this is shiny new, so we've added in Creative Sensor Technology. I have another one on here, and as we get more manufacturers, they'll be listed on here, and you go, okay, there's Creative Sensor Technology, let me expand that. This is their 4 products: the combiflow, the flow sensor, the isoflow, and the isoflow relay. You can now go to one. I'm going to go to flow sensor, and let me click browse to see what they are. Well, here's my T type, and here's my paddle type. I'm sorry, the saddle.
Saddle
mount.
side.
Yeah, saddle mount. I said paddle. I was looking at P and saddle at the same time. Paddle. So obviously this one is 4, and it even says on here right in the middle, 3 and 4 inch. And it gives an operating range for it, and gives all the specifics about it. And if I go to the first one, it's a 1, 1.5, and a 2 range, and their operating range. So that's the one I want. So I'm going to say OK to that. and say, okay, that first one's the one I want to add to my project. It's been added in. I'm just going to go to this layout place, and I'm going to erase these details on the next project that I do here. The next one, I'll go to my detail manager. There it is. I'll place it into the drawing. I've got to give this a sheet number, and then I'll let it be detail 1, and I'll drop it in and check it out. So basically, we're using our new detail bubble call out. We feel this is a good idea on all of our details now, primarily because of simplicity and translations. So it kind of is making logic for us in a couple of ways, and we're going to shift to that. And as we shift to that, when you save one of your details, you can extend them. I don't want to go into that too much, but when I'm putting a template around a detail, I have these width extensions here from 1/4 to 1/2. The reason that was added was because our standard detail module would end here, and that would be fine if I'm putting all this text in there. But if I'm putting the schedule of detail bubble calls, I want to make this a little wider. So this detail got a little bit bigger, but it's the detail that Norm showed you, and this is available. I just added it. Actually, I just downloaded it. That may seem weird. You can get this exact same detail if you add a detail from, and I'm just going to go here and click Add. If you go to FX Details, go down to Irrigation, all of these details I don't have on my computer. When I added it to my project, it downloaded it from our website into my project. Now I have it on my computer. And what you can do is this grows. This FX Details is going to be a really big deal. It's going to have not hundreds but thousands of details in it within a year, I predict. And they're going to be, every one of them is going to be juicy, meaty, lovely, like detail candy for everyone. And you can move them around. You can say, oh, I like your details, let me move it on there. So let me add another situation on there. So I added that detail right from our system. I'm going to go to a situation where I have one point of connection. I'm going to have one flow sensor. But I have 2 controllers that are operating it. So I'm going to add that. Let me make that project active on here, project 2. And I'm going to go to the Irrigation Manager, Auxiliary Equipment. I'm going to add a flow sensor. I'm going to go to CST, and I'm going to add one of these. This time I'm going to pretend this, because I got 2 controllers, I got this really big main line, 4-inch main line or something. So I'm going to add the saddle type. I'm going to add the 3-inch one for this particular project. There it is, but I also have to add something else on here. I got 1 controller, and I've got I've got 2 controllers and 1 flow sensor. So I've got to split this in there. So let me add back to flow sensor, back to CST, and what I want to add, I can figure this out by just reading what these are. combiflow allows 2 flow sensors, that's not what I want, to connect 1 controller. isoflow, 1 flow sensor with 2 controllers, or with 3 to 6 controllers. There's 2 different options on there. That's the one I want. 1 flow sensor, 2 controllers. And there it is, 1 flow sensor with 2 controllers, or I could do a bigger one, which I'll do later. So I'm going to add this to my project also. And I want to put those details in, and it'll be pretty cool. So let me drop that equipment in. This is the flow sensor. Let me place it. I'm going to put it right here. Again, it asks me what it is because that last one I put in, this is a different project. It doesn't know I entered that. No, I'm just going to do FS again for the flow sensor, or F2, F3 if I have multiple ones. I'm also going to place into this transmitter, and I'm going to put it near the controller because it is a transmitter. I'll just call it FT for flow transmitter, something like that. Let me now add the details to this particular project and drop them in. Kind of intriguing. I'm going to come up here, go to auxiliary equipment. Let's see, there's my there's my flow sensor. Let's see, this is the isoflow. I've got them a little confused on here. Okay, the ISF 300 is the transmitter. Okay, so that's the transmitter. Let me hit a detail for that. Again, I'm going to come back to the FX details, go to irrigation, CST, that's the ISOFlow. Now, the question you have to ask yourself, and I can browse through here, is it a normally open or normally closed master valve? Let's say this is a normally closed, and it would be this one right here, the ISF 300, which is right there, and then here are the other ones on there. Obviously, this one is for more than 2 controllers. This one is for 2 controllers, and let me add that one with a normally closed master valve. I've added it to my project, and it is hooked with this. Now I'll go to the flow sensor. This time, I'm sorry, go to the detail for the flow sensor. I'll still pump up here to FX details. I'm going to go to my flow sensor, but I have the paddle mount type, and I'll add that to my project. And now it is associated as a detail with those items. So when I run the schedule, it's going to know where exactly they are. So I go to my detail manager. There's my flow sensor, the paddle mount type, and I'm just going to call this sheet L1 again, and it drops in. And now I'm going to go to my second one, and let's see if something works. I've never tested this, but we're going to see. For downloadable details, I have a reference to another detail, and I'll drop that in to my system. It drops in, but you know, this is interesting. It dropped in. I placed those 2 details, but I got yet another detail added here because I need a relay for my normally closed master valve. I got that detail added because I have that call out within a detail relating to another detail. So we're making it easy for you. You don't even have to know I need this. You know it. I mean, you should know, it's sort of I need another detail, but we control it for you. I'm going to place this in as detail number 3 in here, and I'll exit that, and notice this filled in with detail. So running my schedule for this, and I'll run it just off to the side to make sure details are involved. Oh, I see more than one point of connection. So I've got my, here's my flow sensor, here's my ISOFlow transmitter. I can go up to where it says to go for this transmitter right here, and that says to go to this particular detail, and then I'll find that detail. So while I'm referencing this detail once, it's pointing to the second one also. So that situation was one flow sensor with 2 controllers, and I need this flow transmitter by Norm. Are you there?
I am. I just had to turn my mute button back on.
Oh, thank you. Do I put a flow transmitter in both controllers or in just one of the controllers?
No, just in one of the controllers, and that detail will show you that it is then just wired over to the second one.
Okay, very good. Thank you. That's this detail here. So there is the ISOFlow put into there. And these situations happen. Very large point of connection, but you have satellite controllers out in the field to control things. So that situation happens. Another situation is still one master valve here, but I have more satellite controllers going out. I have up to 6 of them, or at least 6 to this one transmitter. So what I would add there, of course, is the, and let me make that project active. Now I get rid of all the data for the other stuff. I'm going to add a flow sensor here. And I'll add a big one again because this is a big deal. It's a 4-inch this time. And I've added that. And let me add on the flow sensors CST. I'm not sure which one to do. Oh, yes, here it is. The ISOFlow, 1 flow sensor to 2 controllers, or 3 to 6 controllers. And I have 4 of them on there. That's what I want to do, and I want to pick this one that says 3 to 6 controllers, add it to my project, and now I'll place those in there. I know the ISOFlow is that transmitter, so here's my flow sensor. Let me place this stuff into the drawing. Again, I'm just going to call that my flow sensor. Now, Norm, I'm going to put this transmitter in here. That would be this guy here. Do I put it in how many of these controllers?
Again, you just put it in one, Dave, and I'd probably, do it at what, probably the closest one to the point of connection.
Okay, and I would like to note we have up to 2,000 feet of run for these wires. How would you express what the difference? You've got these way out in the field here. How far can you get from your flow sensor to, let's say, these various controllers here?
Well, typically, we use the number 2,000 feet to say that you can go from the flow sensor to the controller or to one of these ISOFlow devices or combiflow devices, and then from that point, it's again a similar 2,000 feet to the longest run. What you're going to be doing with these is obviously bringing pairs of wires to each controller. Now, whether you do that as a spoke or whether you do it as a serial type of thing depends on what's the easiest way to show the wiring, or what's the path of the irrigation zone lines or main lines or things like that that would make the wiring path more convenient for the contractor. But in the detail, it does tell you the numbers of wires necessary, and you'd have to incorporate that into the construction instructions.
Okay. And I haven't added yet a detail for this. So you're saying from this flow sensor to this transmitter, I can't go over 2,000 feet, right?
Well, we'd like to, if you had, that gives you a pretty good distance. If you had to go further than that, we just would suggest that you call us and we talk about maybe increasing the wire size or the power size or something like that.
Gotcha. Let's pretend, this is certainly not 2,000 feet. Then from this controller to either each of the others in a spoke or serial, I'm still from here, it's 2,000 feet to there. Is that right?
Correct.
Or is it still from the flow sensor adding it up?
It's again, you can start over again with your 2,000 foot measurement, but obviously it's the path of the wire, not as the crow flies.
Gotcha. So I had, let me see what this is. This is my transmitter here, the 306. Let me pick a detail for that. And that was, that was an ISOFlow. I had the 300. The 306 is for multiple controllers. This one's with a normally closed valve. So let me add that detail to my project. I won't add the detail to the flow sensor, and I'll just get rid of these real quick. And I want to place that detail into the system. And I have this one detail here, the multiple, and I'm going to place that, and let's look at what that's going to be doing.
We also have a question. The question is, should the flow sensor be after the master valve or before, or does it matter?
It matters.
Well, I've gone
according
back
to Bill.
and forth on that, and each designer may come up with his own idea. If you kind of think about it, it's probably inconsequential as long as you have the correct amount of straight pipe upstream and downstream. You're going to stop the flow with the master valve no matter whether it's before the sensor or beyond it, and you're going to be able to it may be the condition of the job where you want to keep the flow, the pipe full of water as it goes through the flow sensor. It just will give you, better totalizing and things like that. but it can go either way. And I've got probably as many consultants that'll argue for one way as the other way.
Probably true.
So it's the simple answer to it, and I create all kinds of arguments every time I say it, is it doesn't matter.
Okay. The consultant that I was working with on this thing said to put it right after the backflow, or somewhere after the backflow, in between the backflow and the master valve, was his opinion. But,
and that's certainly valid, Dave. And what I always say is you want to put the master valve and the flow sensor as close to the source as you can. That way you can shut off the biggest portion of the main line, that's possible if there is some kind of a leak or a failure.
Gotcha. So this is the controller. I'm sorry, the ISOFlow with multiple. It's normally closed master valve with one flow sensor and 3 to 6 controllers. And this is basically the wiring for them. And I've got that detail. And if I go back to my detail manager, boom, that detail actually got added. And I'll let it be detail 2. So I drop that in, shift back to here, and then this is filled in. So you need more than one detail, but you don't have to be reminded of it. It just automatically goes for you. The next situation that I have would be number 4, where I have more than one point of connection, but I only have one controller. The reason is probably a 2-wire system where the controller can have hundreds of valves to it. But I've got several points of connection, in this case 2 points of connection. So I'm going to need 2 flow sensors for them, but it's going to one controller, so I need a combi on there. I'm not going to add the flow sensor to this project. You've seen that, but I will add the combi. Let me make this project the active project. This will be project number 4. And I'll come up here to add that, going to auxiliary equipment again. I'll go to flow sensor. I'll go to CST, and it's the combi. Now, the combi description says allows 2 flow sensors to connect to one controller, and that's exactly what I want. So let me go to that. I don't have any options. There's my option. I add it in. Let me hit the detail for that. Again, I'm going to go to FX details here. Here's the combiflow, and let me just browse them. Let's see, this would be a situation with more than 2 points of connections, and this is the one with 2 points of connections or 2 flow sensors right here.
We also have a question.
Okay.
In a looped mainline configuration, why is it necessary to utilize 2 sensors as opposed to a single sensor before the split?
If it's before the split, you can use just a single sensor. What probably my little diagram didn't show was we had a situation where wasn't enough straight pipe discharging from a booster pump before we went into the T that divided the flow in 2 directions. So we put 2 sensors, one on each side of the T. But no, if it is a loop system and you have the ability to get a straight piece of pipe section before the branch, then that's fine. You'd have a single flow sensor.
Okay, very good. Let me see, I was going to add this to my project here and put that in. But that combiflow is the one to put into. Let's check out this detail on here. I'll go to the detail manager. It got added to my project. There isn't a reference to another detail on here, so I'll just drop that in and check it out. It's a pretty big detail, and it's basically showing what you do when you have two different points of connections going to one controller, and it's, as it says in here, the sensors may be same or different sizes or different, one could be the T, the other saddle, all kinds of things like that. And that's a situation that could arise. The last situation that we have here is more than one point of connection. I happen to have 3 of them and one controller, and I look at it as there's a couple of reasons you would have that. Number one is, again, you have a 2-wire system where the controller has hundreds of stations available, and you can accommodate more than one point of connection. Or you have a situation where maybe it's an old college campus where you're trying to modernize it, and there's a whole bunch of small points of connections coming off, but you're going to modernize it by taking these 4 different controllers and putting it into one. You're still using these 4 or more points of connections, but you have one controller, but you want to modernize it by putting in water safety features of having a flow sensor and master valve at each one of those points of connections, and those are connected to that one controller. So that can happen. What I would add for that, and let me make that project the active project. Whoop, wrong one. Go to auxiliary equipment. Guess I had that. Let me get rid of these 2 guys I had in there. CST. So let me see. You want, help me out here a second, Norm.
What you get, it's still going to be a combiflow application, Dave, but you do have a detail that shows that you can put these in series with each other.
Got you.
And I know
so there's
you have
my combiflow. Let me look at that detail here. Okay, let me browse here. So I put in this detail with 2. Now I'm looking at a detail right here. How many combiflows am I putting? I'm putting more than one combiflow in this.
Correct.
Right?
You have a combiflow will handle 2 flow sensors, but if you had a third, you can take the output of the first combiflow as the input on one channel of the second one and add a third flow sensor to the other channel of the second one.
Let's add that detail to it, and we'll look at that detail to see what you're talking about on that. So I've added that, given it a detail. If I go to place that, I've got my transmitter here. I've already pretend we've already placed our flow sensor. I'll place this. I'll put one there, and I'm going to call it flow transmitter. And now I do exactly the same thing again.
No, well, yes, you would. You'd have 2 of them there.
Okay, I can leave them. If I put the exact same thing in, it's going to remember the combination of letters I give it, so it'll just put it in twice. And it is identical product, correct?
Correct, it is.
Okay.
It's
Let's
just
look at that
just
detail.
allowing you to put them in series with each other. When you there you
Let's
go.
Place. We'll place that detail in, and we'll check it out.
And we have another question. Are you guys okay for that?
Yep.
Why is the isolation relay necessary?
The isolation relay, the IsoFlow does not isolate the master valve circuit from both controllers, and there are a whole slew of reasons why you don't want to feed a single master valve with 2 different controller master valve outputs. You'll get some cross-feeding or back-feeding into the controller, and you can damage it. So you always want to isolate multiple controllers that are running the same master valve. You'd want to do the same thing, Crystal, whether you were hooking it up to a with an IsoFlow or not. It's just whenever more than one controller is running a single master valve, there should be an isolation relay or some way to isolate the 2 controllers from each other.
And that's what this detail was showing on there.
Right.
And this one does not need an isolation relay. Is that correct?
No, because
Or
again,
just,
it
right.
would be a separate function of whatever they're doing to control the master valve.
Okay, so here we have more than two, and how many are we talking about? We're putting, we can have, let's say we had four, we can have two of these combo sensors, and if we had five, we would have to have three of them. Is that correct?
No, whatever it is, it's one number less than the number of flow sensors. So if you had
Okay.
three flow sensors, you need two combiflows. If you had 4 or 5 flow sensors, it would either be 3 or 4.
Okay,
It's
gotcha.
always,
In regards to that, they said, can you read 2 flow sensors individually on one controller, such as per program?
only if the controller is set up to have 2 flow sensor inputs. And there are some that do that, but no. What the combiflow is doing is it's allowing you to read the 2 or more flow sensors on the single input channel of the controller, so you can't read them individually.
And why would you want to read them individually? Is there, I mean, I guess I can think of some reasons. Can you think of some reasons
Well,
offhand? Or?
well, we've had some where people have wanted to keep totals separate, and again, it may be alternate sources of supply, like a alternate water supply or rainwater harvesting, and they want to keep totals and things separate from that than they do from a potable water connection. But
Mm-hmm.
and it can be done. And that's again the kind of thing that I say, call our customer service line and we'll help you with it. But we have had some where we've totalized separately and then come out of 2 separate totalizers and combined the flow to go into the flow input of a controller in terms of alarm and shutdown features.
Mm-hmm. And we do put, I think, we put the telephone number on here for that very reason,
Yes,
right
you
on
did.
every one of these details. So to me, communication is a good thing. And so definitely call them up if you have any questions at all on what you're trying to do. But that is, unless you can think of something, that is my particular story for these 5 different situations on here. Is there anything you would like to add to that, Norm?
No, I think you did a good job of kind of navigating around your software, Dave, and giving some different examples of different things. And you know, the only thing that I could say is that we welcome questions from the field. We'll be glad to work with anybody to customize some of these things, and we will, I would guess, continue to add details and add you know, information as we get more information or more different types of applications from the field. We'll be sure and help out with more details and more information on both LandFX website and our own.
Sounds great. And speaking of detail revisions, I just want to tell people, don't run out right now and load those details. I have to make a couple of more. We had some revisions come in this morning to them. I want to make those. I'll do that within the next couple of hours. So wait a couple of hours, and then you can jump into this and download those details. So
Well, that sounds
that
great,
sounds
Dave.
great.
We are
And
very excited to be part of your expanding family of product offerings, and would be again more than happy to work with you on products as we develop them. We will get them into your hands so that you can include them in your design package.
that's great. I think this is real beneficial to the folks out there. And it is, the world is becoming way more complex all the time in every respect, and certainly in this. We've gone through such situations and different details, and we do have to master that. If we design irrigation systems, you've got to master this technology and figure out how you're going to do it. So we appreciate you being there, Norm, and helping us out, and I hope everybody enjoyed this, and I just want to thank everybody for coming.
Well, and I add my thanks too, and I'm glad to be included in it, Dave. So let's leave it at again, one final word, that if you have a question on flow or something, we'll be glad to answer it for you. And that comes from either Dave, you folks at LandFX, or from any of your subscribers out in the field. Feel free to call us at any time.
Very good. Thank you very much. And everybody have a good day.
All right. Thank you for having me. And everybody, I echo that, and have a good day.
All right. Goodbye now.
Bye.